You ever stop and think about how you can search your university library's website and somehow find a book that's sitting on a shelf halfway across the world? It really does feel like magic, right? Well, it's not magic, but it is a kind of secret language. It's a hidden set of codes that connects pretty much all the recorded knowledge in the world. So let's dive in and pull back the curtain on this invisible architecture that keeps our information from descending into total chaos. And really, this is the core question. Just imagine, for a second, if every single library had its own unique system for writing down a book's title, its author, the publication date, it would be a complete mess. A library tower of Babel, if you will, where sharing anything between different systems would be next to impossible. So to really appreciate the solution they came up with, we first have to understand just how huge the problem was. We are talking about a world of total information chaos, where incredibly valuable knowledge was just locked away in these isolated, totally incompatible systems. This really gets to the heart of the two competing needs libraries were juggling. You had your internal or local formats. Think of it like a library's private shorthand. It worked great for them, inside their own walls, but it was basically gibberish to anyone else. What everyone needed was an exchange format, a universal language that would finally let all these different systems actually talk to each other. And this wasn't just about solving a technical puzzle. It was a huge philosophical idea. The ultimate goal was something called universal bibliographic control. And that name sounds a bit intense, but the dream behind it was beautiful. To move from these isolated little islands of knowledge to a single global network, to make every publication accessible to literally anyone on the planet. Okay, so how in the world do you solve a problem that big? Well, the very first step was to create a set of rules that humans, the librarians, could all agree on. They needed a global grammar for describing books, and that grammar was called ISBD. The ISBD, or International Standard Bibliographic Description, was born out of a meeting back in 1969, sponsored by the International Federation of Library Associations, or IFLA. It was, for the time, a revolutionary idea, an international agreement on exactly how a book should be described, no matter where you were in the world. And you know what? They kept it beautifully simple. The whole ISBD framework boils any description down into just 8 distinct areas. That's it. 8 simple parts. This structure was the first step to bringing real order to all that chaos. And the real power of these 8 areas is just how logical the flow is. You see how it works? It starts with the absolute basics, the title, and then it moves step by step into more specific details, like the edition, the publisher, what the book physically looks like, and finally, it ends with a totally unique identifier, like the ISBN. It's this incredibly intuitive sequence that guarantees consistency no matter who's doing the cataloging. And this right here shows you the incredible level of detail we're talking about. The standard didn't just say, oh, include the publication info. No, it dictated the exact punctuation used to separate everything. A period, a space, a dash, and another space. This hyperspecific grammar meant that even if you couldn't read the language a book was written in, you could still look at the record and know exactly which part was the title, which was the publisher, and so on. It was genius. But, having a universal grammar for humans was only half the battle. The next great challenge was, how do we teach computers to read and understand all this new standardized information? And that is where MARC enters the story. MARC stands for Machine Readable Cataloging, and it's the perfect name for it. If ISBD was the grammar that humans could read, MARC was the digital container built for computers. It was a format designed specifically to take those logical areas from ISBD and encode them in a way a computer could read, process, and most importantly, share. So how does this actually work under the hood? Well, the beauty of MARC is that every single record, no matter what it's for, is broken down into 3 predictable parts: a leader, a directory, and the actual data itself. So first up is the leader. It's just a tiny 24-character string of text at the very, very beginning of the record. You can basically think of it as the instruction manual for the computer. It tells the machine super basic things like, hey, this entire record is exactly this many characters long. And by the way, you're dealing with a book, not a map or a CD. Next up is the directory. And this is basically the record's table of contents. It's a super efficient index that tells the computer exactly which pieces of information are included in the record, like, say, an author and a title, and precisely where to find them. This makes navigating all that data incredibly fast. And finally, we get to the good stuff, the variable fields. This is where all that descriptive data from the ISBD standard actually lives.
Each chunk of information gets a numerical tag, and then within that field, even smaller pieces of data are identified by things called subfield codes.
And this example shows you perfectly how it all comes together. That number, 260, is the tag that tells the computer, okay, what follows is the publication information. Then you have the subfield codes. The $A means this is the place of publication. The $B means this is the name of the publisher, and $C is the date. It's this precise, coded language that leaves absolutely no room for error.
Now, the MARC format was so successful that it spread like wildfire all around the world. But just like any language, as it traveled, it started to develop different local dialects to suit different needs.
And you can really see that evolution here. It all kicks off in the US in the mid-60s. By 1969, the UK has its own flavor, UK MARC. But pretty soon, it became obvious that they needed a translator to help all these new national formats talk to each other. And that's what led to the creation of UNIMARC. And that family just kept on growing. Soon you had USC MARC, UK MARC, CanMARC in Canada, and dozens of other national versions. Of course, this created a new problem, which is why formats like UNIMARC and CCF became so important. They were designed to act as translators, or a common ground, allowing all these different dialects to communicate with each other. So, okay, after all this pretty technical talk about tags and subfields and dialects, why should you actually care? Well, it's because this hidden language is truly the invisible engine that powers our entire modern access to knowledge. Seriously, every single time you search an online catalog, or every time your library gets a book for you from another institution, you are using the system that ISBD and MARC built decades ago. It's the fundamental reason why information is no longer locked away in physical buildings, but is available to us from pretty much anywhere. And at the end of the day, what this all means is massive, massive efficiency. A librarian in New Delhi can catalog a book one time, and thanks to this shared language, a librarian in New York doesn't have to do all that work over again. They just share the record. This created enormous economic savings and allowed for global resource sharing on a scale that was just completely unimaginable before. Now, MARC has been the bedrock for over 50 years, but as we all know, technology never stops moving. As we dive headfirst into an age of AI and totally new ways of linking data on the semantic web, it really makes you wonder, right? What's going to be the next universal language for knowledge? What will the next MARC look like?